This is Sentry Governor, an autonomous data governance agent designed for the Fivetran track of the Google Cloud Rapid Agent Hackathon. We are addressing Shadow PII, sensitive personal data that accidentally leak into analytics warehouses. For example, when a Fivetran sync carries raw emails from CRM into marketing table without authorization. This is the largest source of unintentional compilation risk today. Sentry Governor is not a chatbot. It's a reasoning agent. It discovers tables, classifies columns using Gemini, and compare them agent declarative data contracts. It finds Shadow PII. It built a plan and execute remediation by calling a Fivetran MCP server to reconfigure the pipeline. Our architecture is a hardened governor plane. We use FastAPI for the control plane and PostgreSQL for the persist contracts and remediation plans, bridging the gap between data engineering and security. Accountability is provable. Every action is recorded in a Merkle chained cryptographic ledger. If any record is tampered with the database, our dashboard detects the broken chain and surfaces the corruption within seconds. The project is fully tested in mock data and wired for live deployment. Sentry Governor makes automated data governance mathematically verifiable. Let's look at live scenario. A Fivetran sync just moves this data. In our raw CRM table, we have plain text email. This is fine. But look at our analytics table. Those exact same plain text email and card number have leaked here. The marketing team does not need raw emails to analyze subscription plans. This is the Shadow PII, and it's a massive compliance risk. Let's fix it. I just triggered our autonomous agent. Notice it inspects 2 tables, but only flagged 4 violations in the analytics table. Why? Because Sentry is strictly context aware. It uses Gemini to classify every columns, then compass those classification agents our declarative data contracts. It knows the CRM is authorized to hold P, but it flagged the analytics table immediately because the contract forbids it. It autonomously classifies the extract risk columns, email, phone, billing address, and card details. I will approve this remediation plan. Now look closely at our cryptographic action ledger. Every single action, agent, and human is recorded as an immutable chain. Step 1 is a human approval. Step 2 to 5 show the agent calling the Fivetran MCP. Modify column config tool to execute the changes. Each step creates a SHA-256 hash link to the previous one. It is a Merkle routed, tamper-evident audit trail. Even database admins cannot rewrite this history. Now for the final proof. Let's refresh the live database. In our CRM table, the raw data remains untouched. But look at the analytics table. The email, phone, and card are completely hashed. But notice, our non-P columns, like subscription plan and account status, are perfectly preserved for the marketing analytics tools. We eliminated the risk at the pipeline layer without breaking downstream analytics. But what if a rough admin tries to delete these logs to hide their tracks? I will simulate a hack by deleting a log entry directly in the database. But now let's verify. Boom! Integrity check failed. The recomputed hash no longer matches the stored hash, and the Merkle path is broken. The attacker can never make this box green again without the private key. It is permanent mathematical proof of tampering. Autonomous detection, context awareness remediation, verifiable accountability. This is Sentry Governor. Thank you for your watching.